Okay, so we're back to the PowerPoint. When a muscle contracts, this is a muscle twitch. Remember, the skeletal muscle has to be stimulated by the nerve signal and the release of acetylcholine, which opens up the sodium channels, and sodium rushes into the muscle. And when that whole process of myosin binding to the actin sites, active binding sites, the muscle contracts and you have a twitch. So that's the maximum tension or force that the muscle can generate. And the contraction phase is basically about 16 milliseconds. And then the muscle reacts within, sorry, excuse me. Okay, so the muscle then relaxes. Okay, so there's two types of ways that, excuse me. Hello? Yes. Okay, thank you very much. I'll be there. Okay. Okay, that was Central Texas foot specialist. I had a sore on the bottom of my left foot. So when you have repeated stimulations of a muscle, you can see that following each contraction, and if the frequency follows before the muscle can relax, you start to build up tension. Incomplete tetanus is when you have the muscle contracting, relaxing, contracting, relaxing. If the frequency is increased, the muscle will stay and develop maximum tension or maximum force. So complete tetanus is when the frequency of the stimulation from the axon, from the nerve, causing release of acetylcholine and allowing sodium to enter and allowing the contraction process to take place between the myosin and the actin. So that's complete tetanus versus incomplete tetanus. Then we have motor units. So the number of nerves attached to muscle fibers, that's a motor unit. In the fine muscles of your eyes, very few fibers are going to be attached to nerves because you have to have very small and localized and generation of little tension. If you have enormous muscles like the sartorius in the thigh or the vastus lateralis and so on, you'll have many more muscle fibers attached to a nerve so that different motor units can establish much larger tension. So all voluntary movements are usually subtetanic, and to generate increased tension or force in the muscle, the motor units will be recruited. So you increase the frequency, but you stimulate more muscle, more motor units. So tension, resting muscle is generally in a resting tension so that you can have bones and joints stabilized. You're able to sit, walk, be still, sleep. This constant state of tension and muscle tone helps prevent atrophy or wasting, muscle wasting. Okay, so we have isotonic contraction. So isotonic means same tension. So the muscle stays in lifting a baby, so the tension of the muscle stays constant. Isometric contraction means same length. So if you're holding a baby at arm's length, you're going to have contraction where the length of the muscle stays constant and the tension can vary. So that's isotonic contraction versus isometric contraction. Okay. Muscles can elongate, but all they do is pull, they don't push. So when a muscle elongates, it's elastic forces of the connective tissue that resist that. But as we move our joints and as one muscle contracts and one muscle relaxes, we have to have a constant agonist muscle and an antagonistic muscle that allow movement, walking, coordinated playing of tennis, for instance. So uh, muscles are constantly in muscle tone, or they've been stretched and they contract. So muscle has, uh, first of all, it has. Well, let's stop here and come back to this. So let's go back here. Stop recording. Stop recording.